Welcome you guys. So in the last session, we have discussed the 2D scatter plot. And we were using the IRIS dataset. Now in this session, I'm going to discuss the 3D scatter plot. So let's look at how to do a 3D scatter plot. For plotting a 3D scatter plot, Plotly is a very nice tool where we can use Python to create the interactive 3D scatter plot. So first of all, I'm going to write a code and thereafter I will run that code and I will explain you each and everything. So let's write guys should also write along with me. I'm giving you the time so that you can also write. Otherwise, I can simply ping you the code or put this code here. That's I'm not doing. So write import plotly.express as px. Thereafter, write df is equal to px dot data dot iris. Thereafter, write fig is equal to px dot scatter underscore 3D, and thereafter write df comma x is equal to sepal length sepal sepal underscore length, y is equal to sepal width, and z is equal to comma z is equal to petal length petal petal underscore length length. Fine. Thereafter, you have to also mention the color. So let's mention color. color. Color is equal to species. I want to color it by species. So I'm mentioning the color as species. Thereafter, in the last line, you have to write fig dot show. This code will simply plot the 3D scatter plot. So let's run this code. So I got the nice 3D scatter plot. Now let's understand all this thing. So since you already understood the 2D scatter plot, so it will not be a tough for you to understand the 3D scatter plot, I suppose. So even in this plot, so first of all, let me tell you, these are the things that I have already explained you. So this is not a new thing for you. This is simply a code. Import plotly.express as px. This is my data frame. px.data.iris. This is basically I am passing this data frame here, and I am assigning my in x-axis. And because this is a 3D scatter plot, in x-axis I'm using x-axis as sepal length, in y-axis sepal width, and in z-axis petal length. Color, what is this? I want to color it according to the species. So this is setosa, this is versicolor, this color is setosa, this blue color is setosa, this is my versicolor, this red color, and this is my virginica. This you can see this is a green color. Fine. So after that I'm plotting this. Now let's come to the plot and understand. So even in this plot, you can observe that you can easily move around and understand what's happening in 3 dimensions. So earlier, if I go here in the 2-dimensional plot, you are able to understand this 2-dimensional plot in only 2D. But here you can, in this 3 dimension, you can move around and understand the scatter plots, the points that are scattered or the values that are scattered in the 3 dimension. Can you see the 3 dimension? One is my sepal length, petal length, and sepal width. These are the 3 dimensions. But it requires us to do some mouse movement, which is good because it becomes more interactive and we can get a better sense of what's happening. Can you see? I'm doing some kind of event. I can enlarge it. Can you see? And I can move this in this enlarged way. Fine. So we are getting a better sense of what's going on in the 3D. Now let's say if you look at the data from this angle, let me put it at some particular angle. Let's say if fine, this is fine. Let's say if you look at the data from this angle, if you look at the data from this angle, so you will notice that all the setosa, this blue color, all the setosas flower are well separated from the versicolor or virginica flower. This is my versicolor. This red is my versicolor and this is my virginica. And can you see there is a clear separation? Let me also take out this thing. So in the 2D space, we drew line. We are in the two-dimensional space. We have drawn a line, just like a linear line, to separate this setosa from versicolor and virginica. But in 3D space, we could quickly do what we could quickly do. We can plot a plane like this. Let's say like this. Like this. This is a plane. In two-dimensional, since it was a linear, so we are able to do a linear separation line, this kind of line. But here it is a 3D, so we can draw a plane, and this, if you see, this plane is clearly separating these two, this setosa and versicolor and virginica flowers. So what you are getting, everything on this side of the plane, everything on this side of the plane is basically your setosa flower, and everything on this side of the plane, on the other side of the plane, is basically versicolor or virginica flowers. Now the quick thing that I start to realize is that as soon as I start to plot petal length, this petal length, as soon as I start to plot this petal length, a quick takeaway is this: in this space, if I draw a plane, I am able to separate my points better than I was able to do earlier. Because in my 2D scatter plot, I was not able, there was a separation. And if you remember in the 2D plot, this is my setosa. If I will take you to the 2D plot, let me take you to the 2D plot. I will take you, can you see one setosa is like was getting mixed with these two flowers, this setosa. Because this is a 2D and it is a projection of the 3D. So here, but can you see here, there is no mismatch. This thing. So this is my petal length. So earlier we plotted only sepal length and sepal width. Sepal length and sepal width earlier we have plotted in the 2D scatter plot. But in the 3D scatter plot, we have also used this petal length. And when we are doing this 3D scatter plot, there is a clear separation between the setosa and the other two flowers. That's why this petal length seems to have some value for me here. Now, having said that, one of the big drawbacks, let me explain you the drawbacks of this. First, let's erase this. So one of the big drawback of this 3D plot is that it's not easy to print them on a 2D surface like paper or Word documents or IPython notebook. or to do interactive data analysis, as it requires lot of mouse movement. As you can see, although I am able to rotate it, but it requires a lot of mouse movement. So it is basically a difficult task. Fine. So people basically typically avoid doing this 3D plotting if they can. Sometimes it's the need of us of the hour that we have to anyway do the 3D scatter plot. Hence we do it. But otherwise we usually avoid it. But in general, if we achieve the same insights from now not having to plot 3D plot, I think I would take that choice over plotting the 3D plots. Now the immediate question you might get is, okay, we have seen 2D scatter plot, we have seen 3D scatter plot. Is there something called a 4D scatter plot? Is there something? Let me write it here. So is there something called 4D, 5D, or let's say ND, scatter plot? So the answer to this question is, can you visualize a 4D space? Can you visualize 4D space? So my fundamental question is here, are humans equipped to see data in 4D, 5D, or ND space? See, we humans evolved in a three-dimensional world. So we humans are able to see only length. Let's say this is length. This is, let's say, width. And this is, let's say, depth or height. Fine. So we humans are able to see only length, breadth, and depth. So we humans are evolved in 3D world, and hence we can only see 3D maps. And if you think you can see 4D or 5D, so it's my recommendation. You should visit a doctor, because there might be a small issue with how you are imagining the things, because most people can visualize 3D. Of course, there are some animals which can walk on the ground, which even cannot visualize the third dimension. Those animals are basically small insects, and those that do not fly either. So there are some creatures in the nature which even do not visualize the 3 dimension. They can only visualize till 2 dimension. So what we need to do, so how we can tackle this? The question is how we can tackle this. So we need to come up with some mathematical tools. With mathematical tools. Or you can say mathematical hacks to visualize the data which is in. Because with the normal sense perception, we are only able to visualize the data till 3 dimensions. So we need some mathematical hacks or tools to visualize the data which is in 4D, 5D, or ND. But remember, we have 4 features here: sepal length, sepal width, petal length, and petal width. And this is literally a 4D space that we have to visualize. But we humans did not evolve to see 4D space. But we are very creative creatures. We use maths to understand how to see the 4-dimensional spaces. So the hacks to do that is called pair plot. This is basically a mathematical hacks, pair plot. With the help of the pair plot, we can even able to, this is not exactly a 4-dimensional, but we are able to correlate the things which is in higher dimension, which is above 3D. So this pair plot is our next topic, and we use pair plot to visualize data in 4-dimensional space very elegantly. So in the next session, I'm going to discuss pair plot. Fine. So that's all for the today. So guys, don't forget to watch the next session. I will be discussing the pair plot, and thereafter pair plot, I will be discussing the histograms, probability density function, and cumulative density function. Like this, we will be moving ahead. Fine. So what we need to do, we have to push our code on GitHub. So let's push the today's code. So what we have studied today, 3D scatter plot studied. Done. Let's commit the code. Yes. Sync changes. Fine. Thanks, guys. Thanks for coming. Let's meet in the next session. Till then, keep learning.